Pluto has a glacier that turns over like soup. Until 2015, Pluto was a few pixels. Then New Horizons went past at 14 kilometers a second and sent back pictures for months afterwards because the radio link was so slow. The largest feature is a smooth, pale plain, about 1,000 kilometers across, and it has no craters on it whatsoever. On a body that far out, where impacts are rarer, but 4.5 billion years is still 4.5 billion years, that means the surface is being remade continuously. It is a glacier, and it is not made of water. At Pluto's temperature, around 40 Kelvin, water is rigid rock. What is soft there is nitrogen, which on Earth we know as most of the air. On Pluto, nitrogen ice is the material that flows. The plain is divided into pale cells, 20 or 30 kilometers wide, with shallow troughs between them. That pattern is convection. Slightly warmer nitrogen ice at the bottom rises, spreads, cools, and sinks again at the edges, the way thick soup moves on a low heat. Each cell turns over on a time scale of around 500,000 years, which is why nothing survives on the surface. At the edges of the plain there are mountains, some of them 3 kilometers high. Nitrogen ice is far too weak to hold up a mountain that size, so those mountains have to be made of water ice, which at 40 Kelvin is strong enough. They appear to be blocks of water ice that have broken off the surrounding terrain and are sitting in the nitrogen, floating, because water ice is less dense than solid nitrogen. Icebergs of water floating in a sea of frozen air on a world we could not resolve at all 10 years ago. Triton goes the wrong way and is colder than anything we have measured. Neptune's largest moon orbits backwards. Every large moon in the solar system travels the same way its planet turns, because moons form from a disk that shares that spin. Triton goes the other way, and it is tilted besides. A moon cannot form like that. It has to have been captured. Triton is thought to have been an independent body from the same population as Pluto, wandering in the outer solar system, that passed too close to Neptune and was caught. Capture is a violent process, and afterwards the moon would have been heated enormously by tides as its orbit was ground down into the neat circle it now occupies. Voyager 2 flew past in 1989 and found a young surface with few craters and a strange dimpled texture that has been compared to the skin of a melon. And it found the surface temperature about 38 Kelvin, which is 35 degrees above absolute zero and the coldest directly measured surface in the solar system. Then it found plumes, dark columns rising some 8 kilometers and blown sideways by winds in the thin nitrogen atmosphere, leaving dark streaks on the ice, all pointing the same way. The explanation offered is delicate and unresolved. Sunlight, very weak but able to pass through clear surface ice, warms a darker layer beneath. Nitrogen under that layer turns to gas, pressure builds, and eventually it breaks through and vents. A greenhouse effect operating a few centimeters below the ground, on the coldest surface we know, powered by sunlight 900 times fainter than ours. Voyager 2 saw it once, 37 years ago, and nothing has been back. There is ice on the planet closest to the Sun. Mercury has almost no atmosphere, and its day side reaches 400 degrees Celsius. It is the last place you would look for ice, and there is ice on it. The reason is geometry. Mercury's axis is almost perfectly upright, tilted by about 0.02 of a degree, which is the straightest of any planet. On Earth, The tilt is 23 degrees, and that is why we have seasons and why sunlight reaches into the polar regions for half the year. On Mercury, it never does. At the poles, the sun stays on the horizon, and the floors of deep craters there are never touched by it at all. Not for a season. Not ever, for billions of years. Those floors sit at around -170 degrees Celsius, a few hundred kilometers from ground hot enough to melt lead. Radar from Earth found the first sign in 1992, bright patches at the poles that reflected radio waves the way ice does. The Messenger spacecraft, in orbit from 2011, confirmed it with several independent measurements, including a laser that found the crater floors unusually bright and a detector that found hydrogen concentrated there. Where it came from is most likely comets and small impacts delivering water over a long time, with the tiny fraction that landed in permanent shadow staying put because it had nowhere to go. There is the same arrangement at the poles of our own moon, and we told that story in the episode about the moon. On Mars, the ice is buried in the ground and at the poles, and that was the episode about Mars. The pattern holds everywhere we look. In this solar system, water is the default material, and sunlight is the exception. Ice does not survive out there because it is cold. It survives because nothing has come along to take it away.